My name is Arjun and today I'll be speaking on the topic string theory. So let us start. So if you're here for learning strings of guitar, so this is not the right place. Today instead I'll be talking about one-dimensional fundamental particles called strings. So these are fundamental particles which vibrate, produce energy, and due to different vibrations, different particles are made. So before I go deep into string theory, let us go back to 1905, where famous Albert Einstein produced the most famous equation E equals to mc square. Well, I think everyone knows about what E equals to mc square is, so I won't go in detail. So he was very happy. He looked for a new project to invest because he had already done special relativity. So he went to a new project and he wanted to find a new problem which he could solve. But the topic he chose was not a problem. So the topic he chose was the gravity problem, which was not a problem at all. Everyone thought that gravity was solved by Newton, and he explained how Newton knew the motion. But the thing is, Newton himself wrote that he could explain why things happen, but he cannot explain how the things happen. So Albert Einstein took up the gravity problem. I will just show you. Albert Einstein thought of gravity as how it could transfer. See, you can imagine sun and earth so far away. So how would gravity transfer transfer to space-time and implement on earth? So that was the question Newton asked and he wasn't able to solve. Well, Einstein got an idea of being the universe is a flat. So I'll show you a animation for better visualization. How Einstein visualized space-time. So he thought that the universe is flat, and when a matter is there, it wraps space-time. So we can see here Earth is wrapping space-time, and due to that, Earth is revolving in it. We can also see Earth here, and the moon is revolving around space-time. So we can usually say that when an object enters the universe, it warps space-time. So it was the basic idea of Einstein here. So during that time, there was another German scientist named Theodor Kaluza. He also thought of a unified theory. Instead of gravity, he chose the other known force at that time. So at that time, there were only two known forces. First was gravity, and second was electromagnetic. So he thought that I can also create a unified theory. So he wanted to use the same game. He wanted to be the same kind of wrapping something. But the thing was, Einstein already used wrapping of space-time to explain gravity, so nothing to wrap. So he thought that there must be additional dimensions to create new forces, hence wrapping of different dimensions, wrapping of different forms in different dimensions. So the thing was that he formed a theory of electromagnetic where he introduced many new dimensions. And someone needed to prove the new dimensions, and at that time his friend Oscar Klein in 1926 proved there were extra dimensions. Well, you asked me where are the extra dimensions, okay? He asked the question, where are the extra dimensions, why can't we see them? And the second question he posed, can we use Theodor Kaluza's unified theory of electromagnetic in real life happening? The first question was answered by Oscar Klein, where he formed the idea of extra dimensions in 1926. So imagine you are trekking. Imagine you are seeing a very, very small road on a mountain, a banner. You will only see it as a one dimension. You will only see a bit, it's like a small side of the road. But imagine an ant is walking down, ant is walking on the road. So you can see if I see from here, we can only see this as one dimension. But imagine an ant is walking on this. It could walk from here to here or here to here. So for it would be two dimension. But from us seeing this marker from very, very far, it would seem it is only one dimension. So he used the same application in hiding the other dimensions. So here is the animation of of extra dimensions. So you see here that extra dimensions are very, very small. So we cannot see them. But imagine from here, if you only see, for example, from here in our universe, you can only see 3 dimensions. But if we zoom in, you could actually see extra dimensions where little ants, here is an ant, are walking in their own dimensions. So this was the concept extra dimension of introduced by Oscar Klein. Now, we'll talk about the string theory. So the second question I told you about, can we apply the unified theory of electromagnetic in everyday things? That question wasn't answered for 50 years or so. And soon Oscar Klein's extra dimensions and Theodore Kalun's unified theory of electromagnetic cooled down. Until in 1980s, string theory was introduced. So what is string theory exactly? String theory states that a string is the most fundamental particle. So I'll show you a video later, but string theory says that the string is the most fundamental particle. During 1900s, atom was not the most fundamental particle. It cannot be undivisible. But later on, by Thomson, another great scientist, Rutherford, they found neutrinos, protons, nucleus, and electrons. And soon, during 1960s, they found that quarks were present inside protons and neutrons. So scientists thought of an idea that could there be a particle which is not indivisible and has no constituents, and that idea became string theory. So I want to show a video regarding this thing.
Imagine I have a beautiful tree that's filled with oranges, and I ask myself, what is the orange made of? How do I answer that question? Well, I want to look deeply inside the orange, so I magnify it. And I magnify it again, and if I keep on doing it, deep inside, sooner or later I begin to see molecules come into view. But molecules are not the end of the story, because the molecules, I can enlarge them. And if I make them big enough deep inside, I begin to see atoms. Atoms are not the end of the story too, because we have electrons zooming around the nucleus, deep inside, mostly empty space in the atom, but deep inside, we see the nucleus. So if I grab that and magnify it, I see that the nucleus is itself made of particles, neutrons and protons. And if I grab one of the neutrons and magnify it, I find yet further particles, little tiny quarks inside. Now that is where the conventional ideas stop. String theory comes along and suggests that inside these particles there is something else. So if I take a little quark and I magnify it, conventional idea says there's nothing inside, but string theory says I'll find a little tiny filament, a little filament of energy, a little string-like filament. And just like a string on a violin, I pluck it and it vibrates, creates a little musical note that I can hear. The little strings in string theory, when they vibrate, they don't produce musical notes, they produce the particles themselves. So a quark is nothing but a string vibrating in one pattern. An electron is nothing but a string vibrating in a different pattern. A neutrino, nothing but a string vibrating in a different pattern still. So if I take all of this back together, I have my ordinary orange, and if these ideas are right, they are speculative, but if they are right, deep inside the orange or any other piece of matter is nothing but a dancing, vibrating cosmic symphony of strings. That's the basic idea of string theory.
So as Brian Dean said, that was the basic idea of string theory. I hope you all got it. So now we are going to talk about different types of string theory, but they are not so important. See, type A, type B, type 2A and type 2B, they are almost similar. So they have 10 dimensional, they think about 10 dimensional, and while others have more than 10 dimensions, this has 21 dimensions, this has other dimensions, but these are not important. The main theory we are going to talk about is the M theory or superstring theory. It is unification of all the string theories. So it's a unification of all the unification. And theory, so here the property is the M theory. So it has 11 dimensions of space and time. That is 10 dimensions of space and 1 dimension of time. It contains strings and brains. As I told you, what strings are. But brains are like sheets where strings emerge from. So this is very important when explaining black holes in string theories. So now we are going to explain unification by M theory. So what exactly? See, the main purpose of string theory is to unify everything in the universe. So the M theory, superstring theory relates all these. Let us study. So there are two diversions here from super theory. The first is supersymmetry, and the second is general relativity. So if you observe closely, this whole thing was done by Einstein only himself. And so we can see the prominence of Einstein in physics. In explaining superstring theory, half of the things are by Einstein. But when you go to the other half, first is supersymmetry, second is grand unified force. Let us start from the end. Let us start from electricity and magnetism. So electricity and magnetism, I think everyone knows what they are. So without TV, without fridge, without credit cards, our life wouldn't be a life, to be honest. So we have to thank these two scientists for also Faraday for connecting electricity and magnetism. So let me just tell you a story of how electricity and magnetism were related. So there was a school teacher, Hans Christian Ørsted, and he accidentally found a relation between electricity and magnetism. So what he was doing is, there was a small circuit nearby him and he switched it on. And he forgot that there was a compass right beneath the wires. And suddenly the compass was rotating and in a very random motion. So he accidentally discovered the relation between electricity and magnetism, which has now led the world to many great things. And James Clerk Maxwell was a scientist who developed many equations connecting electricity and magnetism. You also know the famous right-hand thumb rule. Second, let's talk about the unification of space and time. That was done by, as I told you earlier, it was done by Einstein. So Einstein in 1905 created special relativity. So there were two parts of special relativity. The first part had two laws. The first one said that on every object the physics laws were applicable. So of course, so if there were different objects and different physics laws applied, there would be no universe. Everything would be abolished. And the second thing is the most famous equation of all time in physics, E equals to mc square, where E is energy, m is mass, and C is a constant, that is speed of light squared. And Einstein explained, as I showed you a visualization earlier by how we related space and time. Einstein what gravity in that equation, so that became the general relativity. That's how Einstein formulated the space-time and he converged it. Now let us talk about the nuclear forces, that is weak nuclear force and strong nuclear force. See, the unifying of electromagnetism, weak nuclear force, is like electrons have electricity, right? That's the only thing I don't have to explain that further. But let us talk about weak nuclear force and strong nuclear force. Okay, first of all, weak nuclear force. See, weak nuclear force is used for converting protons into neutrons and releasing radiation, or also used in electronic decays. And strong nuclear force is used for binding protons and in nuclear and atomic decay, as it is written, and breaking the bond. Also, strong nuclear force explains how electrons are attracted towards. We know that in how nucleus is formed and how nucleus. See, if you talk about in nucleus, there are protons and neutrons. So the question is, if there is an element which has more than one proton, so how are, see, if protons are positives, right? So how are two positives not reflecting back. How are they not? How are they still connected themselves? Strong nuclear force explains that. Now let's go to the standard model of particles where I would explain the supersymmetry. I'll come here, supersymmetry. But before we go to supersymmetry, we have to understand what standard particles are. This is the standard model of particles. See, you can see here, all these are quarks. These are the four particles of forces. How forces are able to implement other objects. These are the electrons. And this is the Higgs boson particle, also known as the God particle, which was founded in 2012. So, what supersymmetry tells us is that in order for string theory to work, we have to have a new symmetry in our universe. That is the supersymmetry. What supersymmetry says that all these fundamental particles, there should be a mirror, exact mirror of the particles known as these. These are the supersymmetric particles, and when compared, these are the standard model particles. So for string theory to work, and string theory requires multi-universes, because our universe only has 3 dimensions of space and 1 dimension of time. Though other dimensions could be found in a universe if the string theory is right. But we are considering that in our universe only 3 dimensions of space and 1 dimension of time. What we imagine in different universe, there are different dimensions. String theory requires 11 dimensions. So we consider that other universes have 11 dimensions. For that to work, the standard particles should have an exact replica of their exact mirror image. That is the supersymmetric particles. So you can see the Higgs boson particle is Higgs, and other things. So the graviton is beauty in it. Now we go to unification of grand unified force. Also known as we need a grand united theory. We need a grand unified quantum theory. But unfortunately, at this time, we have reached a dead end. That is what leads to criticism of string theory, that there is no grand unified theory of all the forces. If there was a grand unified theory of all the forces, string theory would work right away. This is where scientists have reached a dead end, and still more than 1 million scientists are working on this grand unified theory.
Theory, it is based upon all the objects following the laws of physics.
Yeah.
Okay, so now I have recently come up with a new concept. I have not come up with this, but I have come in contact with this concept about Planck's velocity or Planck's temperature. These are velocities and temperatures at which, when an object mobilizes, it breaks the laws of physics and it doesn't follow the current laws of physics. There are separate laws of physics for them, which are not yet discovered. So how can you relate with those objects which move above Planck's temperature and Planck's velocity to being originated from the string theory?
See, string theory is unifying of everything. And what we're talking about is special relativity. And to be honest, special relativity, Einstein's main problem was he said this speed of light is constant. And we think speed of light is constant. But in different universes, there might be a different speed of light. Okay, and that was explained. When someone asks the topic of black hole, I would say that Stephen Hawking created a new equation of black holes. It was, I forgot the equation he created along with that, and it had Planck's temperature, which you're talking about. And somehow string theory managed to unify it. So when you're saying about Planck's constant in temperature, and how the object is not following the physics laws of physics, it is still following this string theory.
Right, but this theory created by Stephen Hawking, it could be applicable in another universe.
Yeah, it can happen. I still don't know about that. But string theory is applicable to all the other universes. So, this string theory had already proved Stephen Hawking's equation, and it had Planck's constant in it. So I think we are sure Planck's constant, when applicable to other ones, string theory can be applied to different universes.
What were the new dimensions proposed by Theodore Kulzas?
Theodore Kalunzas.
Yes.
Theodore Kalunzas there could be infinite number of dimensions here. But Theodore-Kaluza, I'll show you the slide. I'll show you the slide. Dimensions were introduced by Oscar Blank, but during his theory, of Theodore-Kaluza said he only introduced one new dimension, so that made a total of 4 dimensions of space and 1 dimension of time. So by introducing one new dimension, he introduced one more force. That's what he thought by wrapping in another dimensions.
Do you know what that dimension was?
Dimension? How can that was dimension of space.
What are the downsides of the string theory?
Well, I am the one who is proving string theory, so I think there is no downfall. But as I said earlier, scientists have reached a dead end of making the grand unified theory of quantum physics. So I think that is dead end, that is the downfall.
Does string have vibrations and all other properties of normal matters or normal particles?
See, strings are creating new properties and new matters. So that string only vibrates. Okay. Due to the vibration, different properties of matter are happening. It's not because string has matter has a property. Due to string, the different properties are happening.
When you said that you don't know what the other dimension is, or you might know, but there is one more dimension of space proven by Kaluza.
Yeah.
So is it like time is one dimension, but then the other 3 dimensions are length, breadth, height? So what could be the force, like length, breadth, height, and?
It could be another thing. I don't know how can you explain dimensionally in our dimension. Okay, I tell you what. The 12D dimension. See, I tell you what. I watched a video not regarding the string theory, but I specifically watched a video of extra dimension. So in that, 6D proved everything. 6 dimensions was everything in one universe. I explained all the properties, all the different dimensions. As I said, when I open the slide of this, it shows that this is the only, I'm talking only the space dimensions here. How space dimensions could curve them and how space dimensions could be very, very small. So they are hidden, so we don't know about them yet. But when I watched a video of 20 dimension, it said that there were 11 universes parallel to each other. So there were 11 of those types of universes, and every universe was parallel to each other. I think you know the concept of parallel universes. So the 12D, that video told me that the 12D, the 12th dimension, was the unification of all the parallel universes.
Can time travel, can string theory explain time travel?
See, string theory is unification of everything. It is not just the unification of time or something. Also, I think it can explain because string theory is unification of everything. It is unification of space time too, and time is a 4 dimension in our universe. So I think it can explain time travel. But when you go deep,
so you're saying time travel is possible?
anything, I don't know yet. When physicists create the grand unified theory of quantum physics, time travel may be possible.
So you aren't denying it. You are saying, okay,
it
yes.
can or cannot be possible.
You're not denying it.
I'm not disagreeing with
Do you have any proof for not disagreeing with it?
I'm saying it can or cannot.
But what proof are you basing that accusation of?
That is because there is no grand theory of quantum physics. So now if you want to go deep, I'll explain why time travel, it's a paradox. Okay, what happens when you go to time to kill your grandfather, were you born or not? It's just a paradox. You're talking about paradoxes and you're formulating a question out of that. So if you go to in the past, you kill your grandfather, would you be still alive to go back to time and kill your grandfather?
That wasn't my question. You are moving your anger somewhere else. My question was, do you believe time travel exists based on your speech and what you spoke? You're not denying it.
I'm not
But
disagreeing.
what are you backing it up with? What? Do you have any evidence?
Whatever. I say it can. I don't know yet if it's possible or not.
So you don't think.
Yeah, that's what I said. It can. It's
So I have 2 more questions.
yeah.
Okay.
So
You are telling that time travel is theoretically possible.
I didn't say that.
Okay, it is possible. Do you agree with that?
I don't know. I don't know about that. But according to string theory, it can prove if time travel is possible or not. Just because it can unify everything and there is no quantum theory of everything.
He's saying that the grand theory of the grand unified theory, it will include the knowledge of the ultimate knowledge of the universe, basically what you're
Yeah, so
saying.
if-
So from that, anything can be derived if it is found. If it is not found, then it won't be derived. It's that simple.
A question. Why hasn't string theory been able to explain dark energy even though it constitutes 94% of the known universe?
Yeah, so the thing is, dark energy, everyone knows there is dark energy, but according to string theory, when I talk about extra dimension and I talk about the standard model particles, there is no say, see, this is the standard model of particles. It's about everything in the matter, from quarks to leptons to Higgs bosons and all the forces. So, according to this standard particle, string theory is being formulated. There is no presence of antimatter in here. So, according to string theory, that is why string theory is not able to prove antimatter. Because we only talk about fundamental particles, and to be honest, dark energy, dark matter, we think. I think dark matter is just emptiness. We are just unnecessarily creating new names to confuse confuse ourselves.
How does string theory prove gravity?
That's gravity. See, I'll tell you, I'll go back again to Einstein. See, there are two main theorems by Einstein. One first is special relativity, second is general relativity. So, see, in general relativity, Albert Einstein he had a thought experiment. So he thought of a person falling down, and he thought of a person in a falling lift. So you know what falling lift is. So he thought that the person's weightlessness when the lift is falling, when the elevator is falling. So by that thought experiment, he included the gravity in special relativity.
Okay, so Arjun, I have two questions. Okay, so they're not related to each other. Okay, so my first question is, as you mentioned, string theory has 11 dimensions. Am I correct? Now, in your whole speech, you have told us a lot about the dimensions, but you haven't told us anything specific. You haven't told us what the dimensions are.
But that's again your question.
Are
I'm
you-
asking the same question.
Are you aware? Are you aware what? Then can't you tell me? You haven't told me yet. That is
Okay, I'll
why.
tell you what.
Name the dimension. Can you name me the
Okay.
dimensions? The 10 plus 1 dimension.
Right now, we know only 4 dimensions of the universe. That is 3 dimensions of 3D of space. That is length, breadth, and height, and one dimension of time. So according to Kaluza, we created one more plus 1 of space.
What was that dimension?
That was the dimension of space. We cannot say it was length, breadth, height, and something else. It's the dimension of space. See, if I draw a figure, I'm taking it to very microscopic level. So it is just like this circular path. Now, if you want to add more dimension of space in it, if you want to add more dimension of space, you can see. If we consider this dimension, here it is. Okay, but if you want to add one more dimension, we could wrap one more time. You seen this? So if you only talk about space dimensions, scientists think that there should be 10 dimensions of space and 1 dimension of time. So let us talk about the M theory, the specification of M theory, if you want to go deep into dimensions. So in types of string theories, these two theories says there should be 10D of space and 1 dimension of time. But in these 3 theories, these 3 specifications, it says that there should be 5 dimension of space, 4 dimension of space, 1 dimension of time, and 6 dimensions that are still unknown. So they haven't explained what those dimensions are. So if you go by these 2 specifications of M theory, there are 10 dimensions of space, 1 dimension of time. But when you think about these specifications, there are 4 dimensions of space, 1 dimension of time, and 6 dimensions are still unknown.
What is the scale of quantum gravity?
Scale of quantum gravity. This quantum gravity is anything from a very, very small string theory to large universes. Are you asking about that matter?
Yeah. Or quantum
Yeah, so it's from string to the whole universe. The quantum theory, see, quantum theory or quantum mechanics. We already know about Newton mechanics. It explains. It can also explain electrons, and it can also explain planets and everything. But the concept of Newtonian mechanics is false. Instead, we'll study in future classes. And there is quantum theory which explains everything from a string to different universes.
How is string theory related to Big Bang?
Well, string theory is before the Big Bang. See, what Big Bang says that in the starting of universe there was a point where every mass was constant and suddenly everything blasted and the whole universe was created. But string theory explains that there was something before the point that was a single string vibrating. The single string vibrating created particles, created everything that was included in the point. There's another theory of Big Bang theory. So there's another theory of forming of our universe. So if you consider string theory, there should be 21 universes right now. So according to string theory, when 2 universes combine, they can form one new universe. So for that 2 universes to combine, they have to have string. So this is how string theory, explains Big Bang theory.
Okay, so So as I said, I had another question. So my question is, can you open the slide of the symmetric particle and the standard particle? Can you open that slide? Okay. Now in this slide, as you can see, there is a standard model particle and there is a supersymmetric.
Yeah, let me get it.
There is a supersymmetric particle. Now my question is, are supersymmetric particles related to antimatter? And if there is a relation between the both, can we say that supersymmetric particles are antimatter?
I think I already said antimatter was not included in standard model particles.
I'm talking about
Yeah.
supersymmetric particles.
So there can be a possibility that these are just antimatter. There's a possibility. I don't know. Scientists haven't still figured out. See, when I go back to unification. In this unification, you can see that the superstring theory is divided into 2 parts. That is supersymmetry, grand unified theory, and general relativity. Okay. So we can say grand unified theory is under supersymmetry. So if we haven't proved supersymmetry, we have proved there exists symmetry, but we don't know yet about antimatter.
Okay, so my question, let me rephrase my question as you're not able to. So the supersymmetric particles, so are these basically the same magnitude of the standard particle but with the inverted sign
No.
as
It's
antimatter?
just mirrored. It's mirrored.
Mirrored.
Yeah.
Right, so mirrored, so it is opposite. The
No,
sign
it's
is
not opposite. It's exactly same. Not mirror as in it's not laterally inverted. It's not laterally. It's just a mirror. Exactly same.
like a parallel thing. Then why are these there if it's exactly the same? I don't understand.
That is because, as I said, in our universe, a speed of light is defined. It is 3.6 or 10 to the power 8 meter per second. But it can happen that there are different speed of light in different universes. So these particles can explain why it is happening where speed of light is different in different universes.
What could possibly be the amount of energy present in a particle of a dark matter?
So you are going to the concept of dark matter where
Or in a string?
in a string, see it's not defined. String has no string. See, string vibrates, okay, and it produces energy for different particles. So I still don't know what amount of energy is present in string. But due to that, energy is produced due to vibration of string. There is no such thing as just a rest string.
And if there is energy, we want to harvest that energy. We have to use it. How can we harvest that energy?
See, energy is produced by vibration of strings, okay? So any energy you want, there should be vibration of string. That's the concept.
What is the factor determining the vibration of the strings and why is it different in electrons, protons and neutrons?
See, the way, see, see, I asked a counter question here. Why does hydrogen have one electron, one proton? Why does helium have two proton, two? See, every particle is different in its way. So string, in order to create different new particles, it has to have different vibrations.
So like it's just a property of it.
It's a property of it.
Like there are different dimensional shapes, such as in one dimensional there is string, a point, and in in one dimensional also there is a line or a ray. In two dimensional there is let's say a square or a circle. In three dimensional there is sphere, cube, cuboid. What shape do you think exists in four dimensions?
See, I think I forgot the name of the shape, but it's like a jar. I forgot the drawing. I can show you the diagram later. But yeah, I think you know about it. So it is something like a jar or something, and there was another jar inside which is not connected inside. It was something, I forgot the name of it. Neos.
It's called a tesseract. It's called a tesseract, but not the kind that Marvel shows, but
Cube.
the actual scientific way.
Yeah.
Can I explain four-dimensional shapes?
Yeah.
No, let's explain. Like this question in specific. There is an assumption by scientists that says there are four-dimensional shapes which are yet to be discovered by humans. They do exist in the current universe, but they are not discovered by humans. They exist in such a way, like there is a cube, and there is one more cube inside the cube, but the vertex is correct. However, the lines are very straight. If you look at it theoretically, it's not possible, because then we think that the lines just coincide and it's just one cube. But due to the bending of space and time, those both lines are straight. However, they do not touch; they're parallel, but only the vertices touch. That is the existence of four dimensions.
See, string theory says uniform and everything, including unification of space and time, is already explained. So when you are saying that there is a four dimension that is bending space and time, how is that possible?
That's possible. It's an assumption. I'm not saying that it
Okay,
is
because in my extra dimensions, the dimension itself covers instead of bending space time, the dimension itself are bending. So if you want to interfere with the space time, there has to be a huge matter in it, like sun. Like I showed you the animation where sun is bending space time. A dimension cannot bend space time because it itself is a space. See here, dimensions are bending themselves, not space time. Well, your theory may be different. I don't know.
Does a spring have enough energy to recreate a Big Bang?
See, I cannot say about one string. Everything starts. I cannot say about one string, but if there are multiple strings, sure they can.
Can string theory prove the theory of multiverse?
They cannot prove. They require the theory of multiverse, because as I said earlier, they have to have different for different field of life. They have to have different universe. That is why we can say that. That is why you can say there is supersymmetric particles. Any more questions? We are in the video.
What are the factors that determine the energy of a particular string?
Of a particular string, I don't know yet about the energy of the string. But the vibration of the string, of course, can determine it. I drink water. You want to start?
Why take string theory into consideration even if it isn't able to give a stable explanation of constants were created by nature with respect to particle physics?
Can you repeat the question?
Why take string theory into consideration even if it isn't able to give a stable explanation of how constants were created by nature with respect to particle physics?
See, as I said earlier, there is a possibility of constants being of different values in different universes. So a string has already proved that there should be how constants are different in different. It can happen. So I don't get the question why you're asking why constants are there. But string theory already proved that these supersymmetric particles can explain why there could be a different value of constants and there should be the same value of the constant in different universes.
और किसी का क्वेश्चन है? ओके चलो बोलो